Hey guys, it's Tom Cherryholmes with the FujiNet project, and we have right here a work in progress status report for what we are calling the Platform I/O version of the code. This is essentially going to be the production version of the code once it's finished. Now, to explain kind of what we've been doing up to this point, we have been taking and writing individual sections of functionality. Things like disk emulation, things like the Wi-Fi modem emulation, things like the network card and in-device emulation. Each of these has been segmented off into its own singular test in Arduino as an Arduino sketch. But this doesn't scale very well for production use. So Jeff Piepmeier came to us and with the idea of taking the individual bits and pieces of Arduino sketches and building it all, stitching it all together as C++ classes and building under Platform I/O, which has a much better build infrastructure and allows us to do things like add and apply unit tests so we can test each piece of functionality as we take and fold it into the production firmware. So the net result from the user's point of view is whereas before you had to load separate tests to test individual chunks of functionality, you now can load one set of firmware that will have all of the features that are planned for the final release. So with that, at least from the user's perspective, everything kind of looks the same, but there are a couple of unique differences that you can see right off the top here. If you look in the host list, you can see the usual suspects for TNFS, and you can see that I also have a local TNFS server here on my network, and I have a TNFS server that's also running on a Google Compute platform that we will take and use for this test as well. But you can see that there are two special host slots that you can define. If you call one of them SD, that means that it will look for disk images off of the local micro SD card slot that is present on the ESP32 versions of FujiNet. There is also an option for SPIFs. If you specify SPIFs, it means it will take and try to look for disk images and store disk images on the internal flash that is present on both the 8266 and the ESP32. So both SD and SPIFs for local storage are supported. We'll actually use the SD card storage here, which you can see I have a whole bunch of different operating systems that I've kind of thrown on here. But I also have a copy of what's called the FNC Tools ATR disk image here. And this is basically a set of command line tools that we will be using for this particular test. We'll go ahead and mount that into drive 2 as read-only. And we will mount everything, let it go to a basic prompt here, and turn off, insert a Sparta-DOS-X cartridge, and turn the computer back on. Within a few moments, we'll see that we have booted into Sparta-DOS-X, and if we look on drive 2, we will actually see a whole set of individual utilities and their associated documentation for all sorts of little things that you can do to control FujiNet from operating systems like Sparta-DOS, like DOS-XL, but also from menu-based DOSes such as DOS2, DOS3. Really doesn't matter. The programs will take and adjust appropriately. You can see, for example, the network configuration. You can scan for networks. You can do things like look at the host slots that you've configured in config, as well as the device slots that you've configured in config. These will be important as well to later as we start making disk images and mounting things in this test. But you can also modify the individual host elements using the fhost command. And you'll notice that for commands that actually require parameters here, it will show you what the actual parameters are and which ones are optional. So if we take, for right now, we'll start by actually creating a large disk image in device slot number 1. You can see the parameters that will be required for that. We will go ahead and place this on on device slot number 5, which is, as you can see, it's an IP address going to a Google Compute platform VM instance way off in the cloud. And we're doing this just to prove the point. So we'll take and create a new disk in drive 1 on host slot number 5. We'll call it that. And actually, sorry, we need to specify the sectors, how many sectors and the sector size. And within a few moments, it will take and create the disk image for us and mount it into place. Am I running? Let me actually take a look. Apologies here. I think I might have accidentally turned off that server for just a moment. Yes, I did. I was trying to clean up from the last test here. Try that one more time. So if a particular server isn't working, it will simply just error back out again. We start the server again, and we'll see that it has mounted this disk image, created it, mounted it, it's ready to go. And if we go do an FLD at this point, we'll see that it's right there, it's mounted read-write, it's ready to go. Now if we look at drive 1 here and we do a directory, we'll actually see that it's not formatted at all. But if we go ahead and run the format utility, and go ahead and create the hard drive image, writes out the directory. Directory is written. Keep in mind that this is being written to a server running way off over in Google Cloud. The Atari really doesn't matter, doesn't care. It's just here. It's now ready to go. We'll start here by taking and making a copy of the FNC tools that we can use going forward here, and we'll copy them over from drive 2, which is actually being read off of my local SD card slot. And you can see here that it's using high-speed transfers here to take and copy this stuff across. Because Sparta-DOS doesn't do well with divisors much faster than, say, Indus GT speeds. I'm not going that fast, but from what I've been told from the people maintaining Sparta-DOS X is that they are implementing better high-speed SIO routines, which will allow for speed divisors all the way up to 0, which is roughly, 127 kilobits per second, which will be roughly twice as fast as what. We'll go ahead and let this complete. I will mention that you can see that for every COM file that's presented here, you will see there's a corresponding doc file with documentation, a manual page of sorts, for all the different parameters and what you can put in those parameter slots. Some of the commands I didn't talk about are feject to eject a device from a slot, as well as fmall, which basically goes ahead and mounts all of the devices in their respective device slot, as well as fls, so that you can list the files in a particular host slot. There's also fnet, so that you can set a particular Wi-Fi network and its corresponding password from the command line as well. Almost done here. And if we do a directory at this particular point, we'll see our tools right there. I meant to put them in the FNC directory, but that's fine. They can go here. Fine. We'll go ahead and I'll show some of the manual pages that come with each utility. See, they're nice and neat. We have a move command. That's fine. It's some variation of the copy command. That's no. We'll just leave this as is. We'll go ahead for the next part here, and we will actually take a copy of one of these tools here. And we're going to go ahead and send it to the printer just so that we can have something. All right, copy. Now you can see right there, it sent it off to a virtual PDF. And if we actually take and go to a web address that's the same IP as the ESP, in this case 192.168.1.7, we open this up in the web browser, we will get a PDF back. And I will do that now just off window here. Now, this gives us, we can see right here, just a moment. Go back to my OBS window here so I can flip over. And you can see printed output. This is using the Atari 820 emulation here, which gives a 40-column printer. You can see right there, just doing great. And we'll actually expand upon this in just a moment to show multi-page output. Before we actually get there, let's go ahead, go back for a moment. We will make a directory called comms. We will go ahead and f-eject. We will go ahead and f-eject 2. And we'll mount in drive 2 from host slot number 3, which is Errata Online, in my case, another ATR called comms 1.atr. And you can see if you're need to tell it whether it's mounted read or write. Let's see here. Second. Let me verify the file name here. Apologies, it's not comms1, but com1. Yeah, there is a bug in the FLS command that I need to fix, which is why I'm not using it at the moment. Go ahead and mount it. We can see a copy of Modem 6.3 and a copy of autorun.sys, which is the handler. We'll go ahead and copy it over real quick, as well as a copy of Modem 6.3. few moments. And again, it's important to understand that I'm copying these things from different hosts located in different places, with the Atari sitting in the middle, the FujiNet adapter basically grabbing things in and translating it for the Atari to use effectively. Doing all of this on the fly. We go into our comms directory here. We can see our R handler, which if we load it, everything in place, we can then go ahead, and I will go ahead and do this just as a test here. We're going to list, sorry about that, my bad, I have to load it first. We're going to go ahead and list it. And I'm doing this one because this is a large basic program that spans multiple pages. This will take just a moment. There are other printing emulations available. Right now we currently have Atari 820 and Atari 1027 with more printing emulations on the way, each with their own matching fonts. There's still a lot to do in this area too. For example, we need to embed the fonts inside the PDF files themselves, but that's coming. It's important to understand that that Jeff has created a way for the ESP32, ESP8266, the FujiNet itself, to generate PDF files on the fly without needing an external library, and thus be able to be fit inside of the limited memory space of the ESP. Now if we go ahead and fetch down a copy of that particular file again, go ahead, just wait a moment for it to come in. About 50% downloaded, 75%, and here. Now, if I go ahead and flip back over, we'll see our printed output. And you can see that this actually spans multiple pages and does so quite nicely. Here we go. The whole A modem source code right here. And it's just spitting it out like it's, there you go. Finally, if we actually go in and load it, we'll see that the Wi-Fi modem emulation is here as well. We'll go ahead and set the baud rate to 1200 bits per second. And there we go. And we'll go ahead and just log off here. We got the point. You can see the modem emulation, the disk emulation with read and write, and the printing emulation are all living together under one roof quite happily together. The next major piece is to implement the network, the end device. Those will be our major 4 devices that we will be shipping as part of the first release. I want to thank everybody who has gotten us to this point. Far too many names to listen, but most importantly, thanks so much to Mozzwald and Jeff Piepmeier for taking all of the bits and pieces and sewing this all together into a production framework. While I've been working on the bits and pieces in Arduino, fleshing out the functionality. But now that the production firmware has gotten this far, I have now switched entirely to the platform I/O code and am using it for further development going forward. Some of you may have noticed that the microphone sounds different on this particular video. And yes, going forward, my original microphone, a blue Nessie, died after roughly about 10 years worth of service. And I have replaced it with a blue Yeti, which is even more amazing for roughly the same price. I'm actually amazed. And I hope you guys enjoy the subsequent audio improvement. As always, if there's any way that you want to help out, please help out. The code is on GitHub. There's an active discussion thread on Atari Age. There is an active discussion on Facebook and a number of Atari groups. If you want to help, if you can help, please help. There's so much more to come. So, okay, guys, until next time, have fun.